Okay student, today our topic is ripple counter. In earlier video, we have seen what is counter, that is counting from 0, 1, 2, 3, 4 and again 0. So counting the event, right? So what is ripple counter or asynchronous counter? The counter in which external clock is only given to the first flip-flop and the succeeding flip-flop are clocked by the output of the preceding flip-flop is called asynchronous counter or ripple counter. So means here first flip-flop is triggered by a clock and second and succeeding next flip-flops are triggered by the output of the first or previous flip-flop, right? So the logical diagram is shown of two flip-flop or 2-bit ripple counter because here have been used a 2 flip-flop. The toggle flip-flop are being used, that is J and K is connected together. If we remember the JK flip-flop, the truth table is as like. So when J and K is 0 0, then the output is Qn, that is previous state, and when J and K is both 1, then the output is toggled of Qn bar previous state. So the ripple counter can be designed using T or JK flip-flop. The flip-flop are used to toggle mode. So the logical diagram is shown of 2-bit ripple counter. The ripple counter make efficient use of flip-flop. The n-bit ripple counter uses n-bit flip-flop which counts 2 to the power n clock. So here have been used 2 flip-flop, so it count 2 to the power 2 is equal to 0 to 4. In this counter, the flip-flop are not clocked simultaneously. The output of previous flip-flop become the clock input for the next flip-flop, and hence it is known as asynchronous counter, right? The inputs J and K of flip-flop are connected to logic 1 here in this picture. The flip-flop act as a toggle switch and the output of flip-flop is complement to the negative going pulses. So if we see the operation, then initially let both the flip-flop is reset, right? So here actually we have don't draw the preset and set, so we have just assumed that the both flip-flop are in reset condition. Then Q and QB initially 0. After the first negative clock to the FFA, so then what happened? The QA is connected to the clock input of FFB. Since QA has changed from 0 to 1, it is triggered as a positive clock edge by FFB. So there is no change in QB because of FFB is negative edge triggered, right? And so the total number QBQA is 0 1 after the first clock. After the second clock, what will happen? That is toggle between the flip-flop. So 0 1 from 1 0. And last third negative, on the arrival of third negative clock edge, FFA toggled gain and QA become 1 from 0. Since this is a positive going flip change, so FFB will not change. So the value will be last 1 1. So the truth table is like this, that is clock, counter output, set output, decimal counter output. So initially the clock is reset, so 0 0. Then first QA will change but QB will not change because this is positive edge triggered, but the both flip-flop is changed by negative edge flip triggered. So this will count 1. Then after second the QA will change and by QA changing, QB will also change because of negative edge trigger. So 1 0, that is 2, then after that 1 1, that is 3, and after that fourth clock, that is 0 0. From 1 1 to 0 0, that is 4. So this is the ripple counter or asynchronous counter, and this is the synchronous counter whose working principle is same as previous. So in this lecture we have discussed asynchronous counter, that is ripple counter, and the same working principle synchronous counter, where the clock is connected to all the flip-flop, that is this clock is connected to this flip-flop and this flip-flop, so it is called synchronous counter. But in asynchronous counter, the clock is connected to only FFA, and the FFB clocked by the output of FFA. So this is called asynchronous counter. And synchronous counter, when the all the clock of flip-flop is connected with the clock pulses. So this is end, and in this video we have discussed synchronous counter and asynchronous counter. Thank you.